Hi there, so this question is about alkenes. Related topics you might want to take a look at include cracking, naming and drawing organic molecules, types of formulae such as structural, skeletal and displayed, types of isomerism, in this particular case position, branch and EZ. Here's the question, pause the video, take a look at it and then have a go. Press play when you are ready for the answer. The usual format applies. Black text is the question, blue is the model answer, and red contains any additional information. This is only a 1-mark question, but I've taken this as an opportunity to go through some ideas associated with what cracking is. So we take a longer chain alkane and we convert that into shorter chain alkane or alkanes, and then also alkenes as well. The reason for that is because there is less demand for the longer chain alkanes. We don't have as many uses for them. There is more demand for the shorter chain alkanes, so for instance you might want to use them for fuel for cars, but also the shorter chain alkenes can be used to make polymers, addition polymers, or alcohols. So we weren't actually asked for the balance equation here. We couldn't give a balance equation. We don't know what the particular alkane is in the first place that we're cracking. But should you be asked to suggest products from a longer chain alkane such as C16H34, the idea is that you know it's going to make an alkane or alkanes and an alkene or alkenes, and it has to be balanced for carbon atoms and balanced for hydrogen atoms. So if it was to make, for example, one molecule of C8H18, it could also make 2 molecules of C4H8. And if we look there, we've got the same number of carbons on both sides of the equation and the same number of hydrogens. So that's one possibility when we crack that longer C16H34 molecule. So to relate this back to the question, cracking produces alkenes. It is the carbon-to-carbon double bond that is the region of high electron density, and as such alkenes are attacked by electrophiles. All we have to do now is draw any alkene which has got 4 carbon atoms. We had to get 1 to answer this question, but how many can you get and can you name them? I came up with 4 possibilities. Here they are. In terms of naming them, we only require 1. In terms of naming them, top left will be but1-ene, 4 carbons in the chain, hence the but, carbon-carbon double bond, hence the ene, the double bond between carbons 1 and 2. We've also got methylpropene, so that's an example of a structural isomer of but1-ene, and it's also a chain isomer because we've got 3 in the longest chain for the propene as opposed to 4 in the longest chain. We've also got the 2 position isomers of but2-ene. Now what is different about those 2 isomers? Well, one of them is the Z isomer and one of them is the E isomer due to the restricted rotation around the carbon-carbon double bond. Only a 1-mark question, however, so if you got any of the structures in blue, that gets you the 1 mark. Thanks for watching. New videos are added regularly, so subscribe if you don't want to miss out. Questions about this video or requests for any other future content are very welcome. Please email or post in the comments. The email address is given below.